Let's just jump right in. Have you ever poured your absolute heart and soul into writing the perfect code only to completely stumble right at the finish line when you try to package it? Look, you are definitely not alone. Today, we're demystifying that incredibly frustrating process of packaging your application into a simple, standalone executable. We're going to transform this whole experience from a stressful pitfall into a polished, professional deployment.
I mean, it really is a shared developer pain, right? You've built an absolute masterpiece, your tests are passing beautifully, but why is turning it into a simple .exe file so surprisingly difficult? Well, we put ourselves through this packaging ordeal for one simple reason: user experience. We package apps so our end users never have to open a terminal or figure out how to install Node.js or configure Java environments themselves. We just want them to double-click and go. But hitting unexpected, highly specific roadblocks right when you're ready to ship, yeah, it's maddening.
Okay, let's dive into this. Here's our roadmap for this explainer. 1. The app packaging puzzle. 2. Node custom icon crashes. 3. Java bundling made simple. 4. Eclipse and missing paths. And 5. Developer packaging takeaways.
All right, starting with Section 1, the app packaging puzzle. Expecting polish, hitting pitfalls.
So why does this final step feel so vastly different from writing the code itself? Well, think of it this way. Developing the app is the journey, but the final executable, that's the destination. And that bridge connecting them, the compilation, the bundling, the resource embedding, it is absolutely full of hyper-specific errors. You might encounter completely corrupted files, totally bizarre command line crashes, or invisible missing paths that make zero sense at first glance. But here's the great news. While these errors feel completely random, the solutions are actually highly systematic once you know exactly where to look.
Let's move to Section 2, Node custom icon crashes, or what I like to call the corrupted icon mystery.
Imagine this scenario, and this is pulled straight from a real-world GitHub issue on the Vercel PK repository. You've successfully compiled your Node.js project into a working executable. Awesome. Now you just want to add a custom icon to make it look professional. So you use a standard, popular tool like Resource Hacker to inject your shiny new multi-resolution .ico file. You hit save, you double-click to launch your newly branded app, and nothing happens. Well, actually, scratch that, almost nothing. Right before your console violently crashes, it spits out this exact heart-sinking log. PK, error reading from file. No way, right?
So what is actually happening beneath the surface here? Well, developers were using generic resource editors, which, works fine for standard Windows apps, but it fails spectacularly for Node packages. The root cause? A generic tool like Resource Hacker shifts the exact byte location of the embedded source code within the file. It literally acts as a blindfold for the PKG tool, preventing it from finding your JavaScript payload. The solution is to switch to a specialized Node-friendly tool called resedit and use a highly specific flag, --no-grow. This brilliant little flag enforces a strict size on the resource table, basically preventing it from expanding and shifting your embedded code out of alignment.
Now, what's really interesting about this slide is the exact meticulous fix required here. Even with the --no-grow flag, if you accidentally append a brand new icon to the executable, the tool crashes because it's literally not allowed to grow the file size. You have to replace the existing default icon. In PKG executables, the default icon is always specifically named 1 in the internal resource table. So you must target it directly by passing --icon 1, path to icon.ico. It's a tiny, hyper-specific detail for sure, but executing it correctly entirely prevents the crash and gives you that polished custom branding.
Moving on to Section 3, Java bundling made simple, the missing bundle.
Shifting gears to an entirely different ecosystem, let's look at a scenario outlined in a fantastic Nokoryware blog post about quick-starting JPackage for Windows deployment. If you're building Java applications today, you absolutely need to know about JPackage. It's a powerful tool included directly with every modern Java runtime environment. Its sole purpose? To bundle your runnable jar file together with a localized JRE. This is a real game changer for user experience. It means your users can simply download your program and run it natively without ever having to navigate to Oracle's website, download Java, and configure their system environments just to play your game or use your tool.
But hey, before you type a single line of code into your terminal, there's a vital procedural detail you absolutely cannot ignore. You must always elevate your command prompt to administrator before running any JPackage commands. Why? Because JPackage isn't just moving text, it's aggressively creating directories, moving files, and generating system-level bundles deep within the OS. Running it as a standard user will frequently result in cryptic access denied errors that will just halt your build process right in its tracks.
To avoid getting overwhelmed by a wall of text, you should approach the JPackage syntax in two distinct phases. First, you have your basic flags, --input, --dest, and --main jar. These represent your core setup instructions, simply telling JPackage where your files live and where to output the bundle. Once you verify that the basic bundle works perfectly, then you add the polish flags. Things like --win console to help with user debugging, --app version for professional versioning, and --icon for your branding. Taking it step by step like this ensures that if an error does pop up, you know exactly which flag caused the whole shebang to fail.
Which brings us to Section 4, Eclipse and Missing Paths, the invisible path. In a fascinating scenario pulled from TensorCloud and Stack Overflow discussions, imagine you followed a deployment tutorial flawlessly. You click Build, and Eclipse hits you with this massive, terrifying error, exception, java.io triception, the system cannot find the path specified. Bundler exe installer failed to produce a bundle. I mean, it's incredibly disheartening. But what this error actually means is that Eclipse is trying, and failing, to utilize an external third-party deployment tool called InnoSetup5 in the background. It literally doesn't know where the tool's located on your hard drive.
The fix here doesn't involve touching a single line of your Java code. It is purely procedural within the Windows operating system. Step 1. You have to manually locate exactly where InnoSetup5 is installed on your machine. Step 2. Open up your Windows System Path environment variables. And Step 3. Append that folder path to the very end of the list. But pay close attention to this detail. You must separate it with a semicolon. Just one missing semicolon or one forgotten path variable renders your entire Eclipse build automation completely useless. Talk about a needle in a haystack, right?
Finally, Section 5, Developer Packaging Takeaways, from Pitfall to Polish.
To synthesize the brilliant solutions we've covered in this explainer today, the crucial point is this. Meticulous attention to your underlying tools, flags, and system paths is exactly what turns source code into a polished executable. First, avoid generic resource editors that can blindly corrupt your file structures. Use targeted tools like ResEdit for Node apps. Second, heavily leverage tools like JPackage to make your Java applications effortlessly portable for your end users. Third, when a build fails entirely and complains about missing paths, your very first instinct must be to check your system path variables. And finally, remember this: the frustration of packaging is a universal developer experience. But as we've demonstrated today, the solutions are entirely systematic and achievable.
I want to leave you with this final thought to reflect on. What has been your most frustrating packaging roadblock in your own coding journey, and what obscure detail finally fixed it for you? Thank you so much for joining me for this explainer. Keep learning, keep building, and keep turning those pitfalls into polish.